Certificate of optimality. Primal feasibility, dual feasibility, complementary slackness. I remember that well. Okay, here we are. Welcome back, everybody. I hope everyone had a good spring break. We'll take a couple minutes and talk about where we are. So I've made a couple of changes to the schedule in response to where we were. You can see I shifted, if you paid attention to the schedule earlier, I shifted down the ISO 95 templates a couple of weeks. This week we're going to do a deep dive into dispatching, talk about that some today in class, and then do some video stuff on that. Then we're going to inject a week of using dashboards. So we'll talk about them in class, what they are, how they work, general structure, next Tuesday, a week from today, and then I'll spend the video module that one going through building some dashboards and that kind of stuff, and then we'll jump into the ISO 95 template. As I sent an announcement today, I have updated case study 3. I extended the due date a bit, and I added this second part of the assignment. Some of the material that I'm going to cover today is going to help you with that second part of the assignment. But I want to make note here, this sentence that says you should explicitly bind the two data tables to the data files so that you and we can easily go back and forth. So from this case study 03, the first version, we had these 3 scenarios where we had 3 order files, 3 material files. For the new problem here, we had a 4th one. So you have 4 sets of data files, and you need to be able to interchangeably go between those. And so I want you to bind those tables. It's going to help you, and it's also going to help us. So more pragmatically, if you don't do this, Grant's probably going to take off, 40 points or something if you don't bind these tables, because it's really kind of painful for him to go through the evaluation. So make sure you do.
Like doing a separate file name for each of them,
like a single model, import the data for a single.
Like how do you, so you don't have to create separate bindings. So if you look, so I'm going to talk about this one a little bit today, but if you look at my data files, here's my order and it's bound, and I've got order C. And so I'll just go in there and say, if I want orders D, I just change that file name.
Okay.
Right, and the material's the same way. So my materials, and it's bound to C. And if I change that file name and do an import, it will import the new file.
So that's what you mean by having
Explicitly bound, yeah. So when you turn it in, I don't want you to turn in 4 separate models. I want you to turn in one model where it's got the binding already set. So when Grant wants to look at, scenario C, he just goes in and changes that file name, re-imports, and he can run however. And this is really how you would use a model like this if you have a scheduling model that you want to do periodic scheduling, like let's say weekly scheduling. Come in Monday morning, read the new order file, read the new material inventory position file, and schedule. And so you would have that binding either to a database or to an ERP system or CSV file or something. So that's really how things would work. So as I said, I'm going to talk a little bit about some stuff that will help you with the second part of case study 3. I'm going to talk about that today. I have some questions that I'm going to answer here, and then I will open it up for further questions. I'm going to then go over a little bit of material, and then I'm going to talk a little bit about the exam. So that is our schedule for today. First question, transfer nodes in the sequence destination column. So this is kind of not really a question, but if you look in the discussion forum, there's a whole thread about this, and I just wanted to point out one thing because it's really useful to know this in Simio. So I'm going to open a version of Simio. This has to do with when you use the sequence destination and you're trying to use the transfer nodes in the sequence destination. Okay? And so what I'm going to do is I'm just going to go in and create a blank table. Doesn't matter what the name of it is. Then I'm going to go in and add a sequence destination property. Okay, and as I mentioned in the video, we want this sequence destination property. We want to have this one property to accepts any node to false. And if you look at the help here, what this is saying is that basically we want to allow values that are related to objects. Okay, That's what we want. Okay, and so what you see when I do this, if I were to go back into my model and say, okay, let's add, I don't know, let's add a server, let's add a sink, and then we'll add our transfer node. Okay, so I have server, sink, and transfer node, and then if I go back to the data table and I look in the pull down, it finds the server 1, and finds the sink, but the transfer node's not there. Okay, but you can type in the transfer node. Right, so if I know I have transfer node 1, that's the name of my instance, I can type that in. And so Simio knows transfer node 1 exists, but it doesn't know it's associated with an object, so it doesn't show up in the pull down. And if I put something that's not an object, like if I just put something like, XYZ or something, it's going to say, wait a second, that's an error, I don't know what that is. Okay, and also if you try to put, if I go back and say, well, suppose that I want, this node, which we know is input at sync 1. Okay, and so if I put that in, let's get rid of this guy and put input sync 1. It recognizes that and then it converts it and says, okay, I think you mean sync 1. Okay, so it converts that for me. Okay, so the reason I wanted to talk about this explicitly is this idea that you can type stuff in even though it doesn't show up in the pull down is pretty common in Simio. There are lots of places where it will accept a value, but you don't see it in the pull down. And there are a variety of reasons for that. The two most important reasons are that sometimes Simio just doesn't know. It doesn't have the context to know whether it should be included. And in other cases, the list would just be so long if you included everything that was allowable that they've sort of pared that list down to the things that are most common. So if you don't see something that you think should be there on a pull down on any one of the pull downs, just try typing it in and see if it'll work. And in this case it does.
It's sensitive to capitalization, right?
Is it? I don't know. Is it? It's a good question. Transfer node 1. Apparently it is. Yeah, sensitive to capitalization, which is one of the very few places in Simio where it's sensitive to capitalization. Thank you. Okay, so give that a try. That's question 1. Where's my, here it is. Question 2. For scenario C in part 1 of case study 3, for some reason, my resource plan, and this also, there's a long dialogue between me and the student on this too. You can read the whole dialogue. And so I thought I wanted to demonstrate some of this because what I'm going to show you is the part that will be useful to you in question 2 of case study 3. So it's basically, okay, well, some of these orders aren't getting done. What's going on? I have no idea. Come to find out, or if you read the thread, basically there are material shortages. So if you remember in the model, let me pull this model up here. Scenario 3, case study 3, right here. So here's my case study 3, and here are my data file. So there's my orders file for scenario 3. There are materials for scenario 3. And if you run the model, so if I just run the model, and I fast forward to the end, and then if I go look at the data file, and go look at orders, scroll down here, you can see a whole bunch of things aren't getting done. Okay, and so this was the root of the initial question I got is, it looks like a lot of stuff's not getting done, I can't figure out what's going on. Okay, so from a little bit of debugging, what you're going to find out is there are material shortages. Because we know that we have these constraints, so we have material requirement constraints, and if the materials aren't there, the orders don't go forward. Okay? So to look at this, I want to look a little further into like diagnosing this problem and looking at some of the things that we would want to investigate further. But as with what I did last time, what I'm trying to demonstrate like a debugging technique when I already know what the problem is. Right? So I know where we're going, but in the real world, I wouldn't know this. Right? I would go through this process, which I actually had to do here because my PhD student generated all these data files. And so I had to go through this process before. Okay, so here's what I would do here when I'm looking at this. I'm interested in these completion date have null values. So the first thing I would do is I would filter my data table. So I can go up here. If you haven't seen how to do this, this is going to be helpful to you. I'm going to go and say I want to add a condition, and my condition is that my completion date is null. And I hit OK, and then it's just going to filter the table. So all the records are still in the table, but I've just filtered it to these ones of interest to me. Okay, I'm looking at these and saying, okay, well, these aren't done for some reason. Okay? And so again, I know what the answer is, so this is a little bit easier. But first thing you might notice here is that if you look at the material name, they're all module C. So all the ones that didn't get done are module Cs. Okay, so you would probably, if you think it's a material constraint, look back and say, well, what does module C have that no one else has? Okay, and then so we can go back in easily, and this is the primary reason why we have this assume infinite little Boolean flag here, so that I can say, hey, let's go check this out. So I know that module C uses component D, and none of the other modules do. It's the only one. So it's a reasonable guess that that might be my material constraint. Right, so I just assume this one is infinite, and then I go back and rerun my model. So then I fast forward with that, go back, look at my data, still filtered. We have a lot less that are done now. Okay, so we look, and now we have a module C, a module B, and a module A, but they're all green. Right? So I go back and say, well, let's go back and say material constraint. Let's go down to my green here. Assume that's infinite, go back and run. And I go back and look at my orders data, and okay, I have no orders, so everything's shipped. Okay, so this is my first thing that's saying, okay, well, I think I have two material problems here. I don't have enough module Ds, and I don't have enough green. Okay, so that's the first step. Second step, I'd like to know, okay, where does this happen? Okay, so where in my model, where in time does this occur? Okay, so I can go back to my materials, right, and go back and run it one more time. Go back and look at my orders here. And I can look at these arrival times, and I can just pick the earliest arrival time and say, well, it's going to be somewhere around there, right? So if I pick the earliest arrival time from my arrival time column, or my release column, right, it's going to be somewhere around that time, because when that order arrives, because I know if it's a module D, that happens in kitting, right? So the module D happens, the material consumption happens in the kitting operation, and the green paint happens in finish. Okay, so since kitting is the very first one, I would say it's somewhere around that time. Okay, so I would go back, if I wanted to explore this, I would go back, and I also have these component inventories. Okay, so if I run my model, you can see the component inventories being consumed. And here is module D here, the one that I know in question. So I'm just going to watch this for a little while. It's down around 100. Now it's dropping, it's dropping, it's dropping. And sometime when it gets somewhere around 0, I'm going to pause it. So it's getting consumed. There we go. Let it go a little bit longer. All right, let's pause it right there. So it's still above 0, so I still have some. Yeah?
Wouldn't it be easier, like, is there any way to trigger a process when a material goes to 0?
There is.
So
You could do that. We exactly did that when we looked at SymBit for replenishment, the very first replenishment. SymBit, we looked at, used a monitor element to monitor the crossing state. Remember that? Yeah, you could do that. So if you wanted to find out exactly, you could do that. I'll talk about that a little bit here in just a second. So here we are around 0. So again, now at this point, I'm going to pause my model, and then I'm going to turn trace on. Okay, because I want to see what's going on here. Okay, and so I'm going to go back. Let's go.
Do you do this so that you don't have as much trace to look through?
Yeah.
Okay.
Yeah, I could leave the trace on the whole time if I wanted to. So we'll let it run for a little while, and then make sure it gets down to 0. It's just above 0 right there. There, it looks like it's about at 0 right now, so I'm going to pause the model again, zoom in, make sure. Looks like it's at 0 here. Okay? And so I'm going to go back into my trace and say, okay, well, let me see if I can figure out what's going on. Okay, I want to see what's going on. Okay, I could read through all of this trace stuff if I want, and you should get used to doing that because you're going to have to do that a lot. But I suspect what's happening is I have this material constraint that's being violated there at kit. Okay, so what I'm going to do is go and filter my trace and say, filter everything out except for kit. Okay, and then when I go down and look towards the bottom, because I hopefully stopped it somewhere near where those constraints kicked in, we can see all of those material availability constraints are getting evaluated here. You know, here's component A, here's component B, here's component D, here's how many it needs 5. Let's see, there are 5 currently available, so we still haven't gotten to the constraint yet. Okay, and so we can meet all of this and figure out exactly which one did it, and then this tells me exactly what time the material constraint happened. Okay, which you're going to need for the second part of the case study 3. You're going to need those exact times. Okay, so we could find it. I could then go back and look and say, well, let's just explore KIT further. So I'm going to go to KIT and I'm going to watch it. And what I'm looking for here is the routing out logic. At the routing out logic, what that is that's the queue, or the station actually, that holds the entities that are waiting to be routed to one of the servers. In this case, there's only one server. Okay, so that's this one right here, order 42. So order 42 is stuck there, okay, because there's nothing in KIT, so it could move there. So it's obviously being stuck by the constraint, by the material constraint. And so if I run further, so if I continue to run for a while, you know, and I could just at this point just jump in and fast forward to the end, and there are all the orders that if you cross-reference this to that orders table, these are the exact orders that didn't get filled because they're all stuck here in the routing out logic and they've been stuck by that material constraint. Okay? So the key here is, first of all, saying, look, I think I have a material constraint, which you would eventually get to that, you know, by looking at it, and then say, well, how do I diagnose it? It's the diagnosing it that's the hard part. Okay, you've got to develop this logic to be able to, I'm going to use trace, and I'm going to use watch, and I'm going to use status plots, and all of that kind of stuff to figure out exactly where I want to be. And I could follow the exact same process. I could assume infinite availability on component D, and then do the same thing at finish and find where I ran out of green paint, which is the second constraint that we violated for this model. Okay, so again, this notion of using logic to say, I think this is what's going on, to then figure out how to extract from the model what is going on is an important skill to have. Very important. Yeah?
So does this model search for materials at the transfer node? I thought that was done at the server.
Okay, so that's a good question. So from the video, you will note, hopefully you will note, remember, you can go back and rewatch that when we have the transfer nodes here, that we did 2 things. We used the select from list, right? So I created a list of all of the input nodes, and for kitting there's only 1, for assembly there's 2, right? And we used the select from list, and we used the overload function, just like we have done many times before. The second thing we did, though, is that we used the constraint, right? So if I look at this route constraint logic, we have this bill of materials constraint element there, right? And if we go back to the bill of materials constraint element, this is basically saying, hey, I want to make sure that the bill of materials is there. And the reason we wanted that is so that we don't let the objects, the orders get to the server. Because let's say that this order 42, if I didn't have that constraint logic at KIT, the order would go into the server and then it would block at the server, but nothing else could get around it, right? And so if you have the constraint logic back in the transfer node, so you don't actually, you check for the availability of the bill of materials before you transfer in, things that are behind it that don't have that material constraint can get around it. I think I demonstrated that a couple times in the video also. Okay? Now, as was pointed out, we could also do this in a little bit more sophisticated way if we wanted to. We could use a monitor step and monitor the inventory quantity on hand for component D or for anything we want, and then set that monitor to be the crossing state change. When it gets to 0, it will trigger a process, and in that process, I could put any kind of step that I want, and then I could put up a breakpoint there, so that it would immediately go into the point where that inventory went to 0. Okay. Now you have to be a little bit careful if you do that, because when you go back and look at the material elements here, there's somewhere here, where is it? Allow partial allocations if. Remember what that does, it says, okay, if I need 4 units of component D and I have 2 units in inventory, if you don't have that set, then it's not going to consume the 2 that are there. It's going to wait until they're 4. Okay, and if you use that logic of crossing state change to 0, you will miss that because you're never going to get it you're never going to consume the 2 because everything needs 4. Okay, so if you set that partial allocation if, then it will partially allocate. And so if I need 4 and there are only 2 available, it will already consume those, in which case you'd cross to 0. Okay, so yeah, you could do that. And that would be, relatively easy thing to do. Well, I would tend to do it more the brute force way starting out, and then maybe move to this kind of more sophisticated method when you want to do more detailed stuff. In particular, what you're going to have to do for problem 2 is do this iteratively to find all the material, when it runs to 0. So I might try to do something a little more sophisticated the second time around. Okay? Any questions for me on that? Okay. That's question 2. Question 3. Is there a reason that we do the setup with the transfer node and 3 different servers instead of using the capacity property of a server? Okay, so let me get my markers. Let's do a little on the board here. So basically, if you look at our finish station here, the question is, why do we do this? Here's my finish station, and here's my transfer node. When I select, I have 3 different ones versus having a C equals 3. Okay, and so with C equals 3, I could be doing 3 at a time, which is very similar to what we see here. Okay, so the reason in these types of models that you rarely see that is because what we're modeling are 3 physical machines. And we're not doing capacity analysis, we're actually doing scheduling. Okay, and so there are a couple issues with using this approach. The first one that you would see in this particular model is changeovers. And remember, in the finish station, we have sequence-dependent setups, right? So we have this color thing where we paint color, and I think we have, what do we have? Green, red, blue, yellow, or something like that. Green, red, blue, yellow. These guys are all 0, and these are numbers. Okay, and so what happens is when an entity arrives, okay, so let's say that we're starting out here at time 0, and the first entity that arrives is blue. So what happens here? Well, that says, okay, well, I'm blue, but I don't have a current state, so I'm not transitioning from something to something else, so there's no setup. But we keep track of the fact that we are blue now. So when the next entity comes and it's, say, yellow, then we say, hey, what color are we? We're blue. We want to transition to yellow, so this guy is the time. And now we update this to our current state of yellow. So it works on this notion of having a current setup state. So that's how the server knows how to read that matrix. Okay? The problem is when we do this is you only have one of them. There's only one current state. So although you can have 3 different entities here, and those 3 entities will all have, in some cases, the correct transition time, the current state is not going to be right. Because there aren't 3 current states, there's 1 current state. That's one of the reasons we didn't do it here. And the second reason is machine failures. Using this model, if a machine fails, then you still have 2 that are running. And using this model, if it fails, the whole thing goes. Okay, so there are definitely places where you want to use this, capacity analysis kinds of models. But for detailed scheduling models where we want to consider these things, you need to do it this way. Okay. For kit and package, we use transfer entity type as select from list. So this question is basically when in our model here, why for kit and package where I only have 1, do I want to use the transfer node? Why not just go directly there? Okay. The first reason is I want to treat these consistently. Okay. So what we're going to see when we get to the ISA 95 template stuff is that we want a very consistent way to model this. So I want to be able to say, here's my work center, and we have an arbitrary number of machines. And that arbitrary number includes 1, but I want it to be treated the same way as if I had 10 or 5 or 4. Okay? Second reason that I want, besides just consistency, is remember we have that material constraint. So I want the material constraint to be at the transfer node before it gets to the server so that I can have things jump over it. Okay, now I could do some finagling to do that here in the output node of where it's coming from, but that's a little bit more complicated because we're routing by sequence here, and when you route by sequence, you don't have that other routing out options to add that constraint, so it's a little trickier to do that. And if I didn't have a flow line, if I had some things that go to kit and some things that say go directly to finish, right? Then I need to have that sequence so that I can have different parts have different sequences, and so it would be complicated. Okay, so instead of making those hard-coded changes, we say, okay, well, let's just treat all of these work centers the same, regardless of how many we have, and that's why we did that initial transfer node. And with this question, again, let me reiterate the fact that there's multiple ways to do these models. It doesn't have to be all the same way, but what we're trying to develop is kind of a common way of modeling these scheduling type models. Okay? Okay, so this one has to do with the add data table from schema. Okay, and so what we did in the video, if you recall, is when I created the materials table, so let me just go back into this model. Back into this model, and we created the materials table right here. I wanted to be able to set this assume infinite, right? And so remember when we do these auto-create, so we auto-create these guys, there are 2 rows that I set. So I wanted to be able to say, read these from the table. And the initial quantity is pretty easy because I can just guess the property name. Initial quantity is just initial quantity. But when we get to this assume infinite, you have to know that property name is actually assume infinite availability condition, not assume infinite availability if. So even though it displays assume infinite availability if, the actual property name is assume infinite availability condition. You have to know that in order to make this initial thing work. Okay? An easy way to know that, which is what I did in the model, so I'm going to get out of this guy here and get in my new model, is by add table from schema. And so what add table from schema does is it says, schema knows about a whole bunch of table schemas and repeat group schemas. And it says, okay, which one do you want? So what I did in the video was I said, hey, let's grab this material one right here. And there are 3 different schemas associated with materials. Okay? There's the material table, and then there are the 2 repeat group. Because remember, we have bill of materials. And for a material, bill of materials is a repeat group because you can have an arbitrary number of bill of materials entry length. There's also a similar one for initial quantities, and that's if you're using lots. So if you're using material lots and you want to initialize not just with one fixed quantity, but with specific lots, you have that repeat group. Okay? So what I did in the video was I just said, all I want to do is grab the material, create the table, and then go in and look at the property name. Which is what I did. I looked at the property name and said, oh, it's, assume infinite availability condition, and then I deleted the table and went and fixed it up. But I could have also just said, well, let's just use this table, right? So what I'm going to do is I'm going to grab all 3 of these, right? So I'll grab all 3 of these, do that. And so it created 3 tables, one for the main material table, one for the bill of material repeat group table, and one for the initial quantity table. So it built all those for me. And now here is the table material, the one that I was interested in before was somewhere in here. Assume infinite availability if. Okay, so it built that entire structure for me. Okay, now could I have started this way, created the material table, then delete all the columns I don't care about? Sure, I could have done that. In this case, I just wanted that one column name, so I chose to do it. To use this mechanism just to get that property name. But one thing to note here, if you look at this, so if I look at my material table here, if I go back to my material name column, and it's set here to the reference type is to reference, which means I have to have an existing material, and then I could put it in that. But what we did is we used auto create. Okay, so if I change this to set the table row reference, and I set this to create, another thing you immediately notice is it has populated all of these initial property values. So it is already pre-set up to use the table entry values for the auto-created material element. You don't have to go in and do that, which I did in the video. I went in and set up those two initial property values. And so if you use this method of the schema, it does all that for you. Okay, it goes in, looks at the schema, has the connections, sets these initial property values. Okay? So this from schema is really a useful feature. It's really a useful feature. I didn't want to do this in the video because I wanted to kind of demonstrate what was going on, but generally I would follow this approach, because it's a shortcut. Okay? Another thing that we'll see later in the semester of where this create repeat group, and so you can make a mental note of this or make a written note of it, is that if you have a custom object, like, we've subclass servers and all of that, you might not have known this, but inside that object, you have no access to the data tables. Right? So I have my AE server, in this example, my ABI electronic server, and inside that server object, I have no access to the data tables in my main model. Right? I have access to those tables in the add-on processes, but in the model logic itself, I can't see the tables because of the object-oriented structure that the AE server is inside the model, and so it doesn't have direct access. But I can create access, and that's where we will see later on in the semester this create from schema is quite useful for developing that mapping between custom object repeat groups and main model tables. Okay, so that's the answer to the questions of where else might this be useful. Yeah, where else might this be useful? Okay? And that's all the questions I got. So anybody have any other questions you want me to answer before I jump in and start talking about what I'm going to talk about? Dispatching? Yes, sir.
In the planning tab, is the material like logging table? Would that be beneficial?
Oh, yeah. Yeah, I didn't talk about that. It's a great point, is that if you go back and look either in planning or you also see it in, where's my ABI electronics? I see it in the planning tab. I also see it in the results. I go back to data, results. So if you're running in interactive mode, I haven't run this one in planning mode, but I have the constraint log. Right? And so the constraint log itself, if you just filter this constraint log down to, I think, material constraint or something, it will tell you exactly when that occurs. And when we get to doing dashboards in a couple of weeks, you're going to see that we do that. But it has all that same information that you would find going to look. You just have to troll through the logs. Also note, since we brought that up, is that we have this option also for the logs and the data tables and everything else to save to CSV. So if you have a long one, whether it's trace or whether it's a long constraint log or something like that, you can always export it to CSV and use Tableau or Excel or whatever you find easier to manipulate, make pivot tables and all that kind of stuff. Yeah, that's a great point. Thanks. Okay, did I see someone else have a question back there? I see another question.
I have a question.
Okay.
We here finish servers use changeover operator. I remember that in previous times we used mass simultaneously Cs. We activated this, but here 3 of them uses the same operator, right?
Yeah, so 3 of them use the same operator because we have the changeover operator is required for finish. Yeah. So
we will use whenever it's available, right?
It's what now?
Whenever changeover operator is available, they will wait for the others, for example, if it's not available.
So yeah, so let's say that I have, I go to finish 1 and I have to do a sequence dependent changeover, and the changeover operator is working at finish 3. It will wait. Yeah, it will wait. So it can't do the changeover without that secondary operator. Okay, but I will note that we could also use this constraint logic. So right here, we look at this thing that I showed before, that we have the constraint logic element here. So if I go back in and look at that, constraint logic element, and I look at bill of materials, right? This is a repeat group. So I can have the bill of materials, but I could also have the secondary resource requirement. So if I wanted to force that availability of the secondary resource, in this case the changeover operator, before I have access to the server, I could do that here. I didn't do it for this model, but you could. And so that would be useful in cases where the changeover operator's busy, but there are orders that are waiting that can go to one of the other two servers that don't require a changeover because they're, using the same color or something, then that would cause them to not block. Okay. Anything else? Okay. Get rid of that guy. Dispatching. So now that we have some of the mechanics down, we're going to spend a little bit of time talking about dispatching and how to use it and things like that. And so dispatching, as we should know, hopefully we do know, that it's selecting the next object to allocate a resource to from a list of waiting objects. That's what dispatching is. And so we see this as jobs at machine. So I have this queue of jobs waiting at a machine, and I'm trying to decide which one. The machine becomes available, which one goes next. Or I have jobs at operators, so I have my secondary changeover operator, and there are 3 jobs waiting to be changed over. Which one goes next? That's a dispatching decision. Objects at vehicles, and there are several different examples of that. A whole bunch of different dispatching rules. The most common ones that you see, first in, first out, or last in, first out, shortest processing time, longest processing time, earliest due date, critical ratio, whole bunch of others that we will see. And what these do is they basically define, dispatching rule defines how you select the next object. That's what a dispatching rule does. If I use shortest processing time, I say, hey, of all those waiting, give me the one that has the shortest processing time. Or give me the one that has the earliest due date. Or give me the one that has the lowest critical ratio, or something like that. In the Simio implementations, you look at having our server, just our standard server. And note that when I say server, I really mean all what are called server-based objects. So server, combiner, separator are all server-based objects. When we subclass the server or combiner separator, then we're still dealing with a server-based object. So it's not just the server object, it's all server-based objects. Right? There are 2 ways this works. Right? There's a ranking rule here, which you see, first in, first out, last in, first out, smallest value first, largest value first. And what a ranking rule does is it says when an entity arrives, where do I put it in the queue? Okay, and so it looks at those existing ones, and if I have it set to say smallest value first of due date, it's going to look at all the due dates and it's just going to fit it in where, in order. We also have dynamic selection rules. So dynamic selection rules, which you see down below ranking rule, a little bit different. So a dynamic selection rule says when it becomes available, execute some logic to choose one. So where the ranking rule just ranks the queue, right, and then you typically take the first one, that's the first element of the queue based on the ranking, the dynamic selection rule says execute some logic to do a calculation, say, on everything in the queue and give me the one I want. Okay, so that's why one's static, the ranking rules are static, the selection rules are dynamic, because it recomputes every time that you do that. Okay, so we've talked about all of these things before. So let me just talk about, I'm going to look at the help here in just a second, but for both the server ranking rule and the dynamic selection, I just have this as a note for you guys. I'm going to open that here in just a second. But before I do that, I want to spend just a little bit of time talking about kind of the generics of these ranking rules and dynamic selection rules. And then in the video module, I'm actually going to do some stuff. So we'll look at a little stuff here in class, but I'm going to do the lion's share of actually using this information in the video. And so if you look at model 2, or in case study 2, you need to look at 3 things. First in, first out, shortest processing time, earliest due date. Okay, and so if I go to case study 2, at least my model of case study 2, case study 2, case study 2, there we go, right there. Okay, let's just kind of zoom in on server 1 here. There's server 1 here, and I just have it set to the default. I haven't done anything to it yet, so I still have ranking rule set to first in, first out, and I have no dynamic selection rule. Okay, and so I'm going to jump over to my data table, and here's my order data table, and you can see down here I have a filter, so I've already done a little bit of work here, that I know which orders immediately go to server 1. Right, so what I created, if you look, I created a filter that says, hey, I want to filter my table and only show orders 17, 22, 23, 34, and 36. Okay, and so I found those numbers by looking at the table, right? There's no logic that I used other than just looking at it. And so if I apply this filter, there they are. Okay, and so there are the orders that when I click go, those are all going to go to server 1. Okay? So I'm going to go back to my model and say, let's put a breakpoint here. Put a breakpoint right here. And let's run to the breakpoint. Zoom in just a little bit. There's part 17. Run to the breakpoint. There's part order 22, 23, 34, 36. That's the last one. Again, I just know that's the last one. So instead of running to the breakpoint, I'm just going to step. Okay, and so what the step does is it says, okay, well, I was at that node. And so when I click step, it said, let's take order 36 and let's put it in its place. Let's use the static ranking rule and figure out where it goes, first in, first out, so it goes at the end. Okay? And then, of course, if I run my model from here, so let's just run for a little while. You can see 17 gets done, then 22, then 23, then 34, then 36. So it's just put them in order. The static ranking rule put them in order, and then they were then processed in that same order. Okay. Now, if I want to apply one of the other rules, like, for example, earliest due date, EDD, I have to know, well, how do I tell it to rank that? Okay, and the easiest way in this model is by using the orders table, the orders due date, right? Because it doesn't change. Once I read the due date in, that due date doesn't change. And because it doesn't change, I'm going to use the static ranking rule. Okay, so I'm going to do my first in, first out. It's going to be smallest value first of orders due date. Okay, and so I can go back and look at my table. Again, another one of those cases where if you don't, you want to get in the habit of being able to diagnose this and see what's going on. So setting the breakpoint, going back and looking, filtering the table are all things that you need to learn how the model works. So if I look and I look at due date and I look at this due date, it's going to be order 17, then order 23, then order 22, then 34, 36. So two things get flipped, 22 and 23, by just looking at the due date, right? And so when I go back to my model now that I have that set, and I just do the same process that we did, go to run and say run it, there's 17, there's 22, 23, 34, 36, and step, and you can see, in fact, 22 and 23 are flipped, right? So they got put in the order. They're not in, first out order. They're now in earliest due date order. You want to see it again? We can go back in and say, well, let's go back to our order and say, I don't know, let's make 34. Let's make 34 be, well, we'll make it be first. So I'm going to go back in and just change its due date to 3 and do the same process and run. There's 17, 22, 23, 34, 36, step, and sure enough, there's 34, first in line. Okay? Does that make sense? It's a really simple process because nothing changes. Okay? Now, if we use a dynamic order selection, it's a little bit different, right? So if I use my dynamic order selection, let's just reset that to 0 or to its default condition and say, let's look at my dynamic order selection. And so we have 3 options here. We have smallest value first, largest value first, and a standard dispatching rule. Okay, so I could choose smallest value first and put orders due date. Right? If I did that, I'd have to use the candidates keyword because to use the dynamic rule, it has to go through all the candidate values. But candidate.orders.due date would work perfectly. And I get the exact same answer that I got before. But you don't really want to do that. It works, but you're wasting a lot of computing power or computing time because nothing changes. And when you use a dynamic selection rule, every time the server's reallocated, it computes that value for every single entity in the queue. Okay, so it's unnecessary in this case, but you could do it. Okay? Where it might become useful to do that is if I say, okay, well, let's pick smallest value first and let's just do candidate orders due date. And if I ran this now, it would execute the exact same way. But we have this other option now too, which is called tiebreaker rules, which I see the ellipsis, it's a repeat group. So I can define a whole series of rules that say, okay, I want to go earliest due date, and if I have ties, like a whole bunch of orders that have the same due date, I want to use shortest processing time from among those candidates. And if they all have the same shortest processing time, I want to use, some other logic. So I can have an arbitrary number of rules that say, use this rule, then break a tie with this rule, then break a tie with this rule, then break a tie with this rule, which you can't do with a static rule. You have to do that with a dynamic rule. Okay, so if you want that, that's certainly one reason why you would want to use a dynamic rule, even though the values don't change much. Okay, so the last thing I'm going to look at, again, I'm going to go through some of these in more detail in the video, but this set of standard dispatching rules. Okay, a set of standard dispatching rules. And here's where I'm going to, before I show one of them, I'm going to jump into help, and I'm going to search. And if you go to server and scroll down here, you can see right here, here's my ranking rule description. I'm not going to read any of this to you. I just want you to know that it's here. Ranking rule talks about what they are. And then this dynamic selection rule, and here's the thing that we're really interested in, is this dynamic selection rules. And so if I click on that, there's some things here. We're going to skip this for a little while and just kind of jump down and say, okay, here is a description of those dynamic selection rules. So you can see the built-in rules, smallest value first, largest value first, and then all of these standard dispatching rules. They're just totally described here in this document. Also note their little comment right under built-in rules, the C# source for all of these is available to you. So for whatever reason you want to create your own dispatching rule and you happen to know C#, there's a template that you can create your own dispatching rules, and their dispatching rule implementations are there. So if, for example, you wanted to create a rule that used a primary and secondary and tertiary rule, but you didn't want to use tie breaking, you wanted it all embedded in one rule, you could write that code. And all of that is available to you. We're not going to do that here, but it's all there. What we're particularly interested in is this set of dispatching rules. Okay, I'm going to do a lot more of this when we get to in the video module. But what I just want to point out here is if you pick some of these, like for example, let's say I do the standard dispatching rule and do something like earliest due date. Okay, so there is an earliest due date dispatching rule. Okay? But notice it never really asked me, well, how do I calculate the due date? It just said, hey, we're going to use this earliest due date. Right? So you're saying, well, how does it know what the due date is? Okay, because when we use the static rule, we said orders dot due date. And when we use the dynamic smallest value first, we said candidate dot orders dot due date. But by using the standard dispatching rule, we don't tell it anything. Okay? Because we have to go back and define it with respect to the entity. So I go to the entity, advanced option, we have this property value for due date expression. Okay, so to use the standard dispatching rule, a lot of times I have to implement this secondary information. Okay, and in this case, that is associated with the entity instance. If you look in the help, it tells you that, by the way. If you look at the very bottom of that page, it says, hey, some of these rules require secondary information like this, and this is one of them. Okay, if I want to do something like, let's see here. If I want to go do, I don't know, lease setup. Again, lease setup, if you have something like this, if I'm processing a green order and there's a green order waiting, I sure would like that green order to come next, so I don't have to do a setup. Right? So we said, use lease setup, but how do we tell it how to compute the setup? Okay, and so there's another option here. If you go look at the advanced option here, expected setup time expression. So it tells you, you specify at the server level, here's how you calculate the setup. And then when the entities arrive, or when they're going to reallocate the resource, it uses that expression for all of the candidates in that queue to choose one to execute. Okay? And same thing, a lot of these rules require other things. So if you do something like critical ratio, there are a series of dispatching rules that have to do with how much processing time is left. Well, if I'm here at S1, I've got to go from S1 to assemble to finish to package. Okay, so Simio has to have some way to say it's going a sequence, it's using a processing sequence because it computes all of that. It's not just SPT on this server, but it's the processing time for this order. And so Simio uses that sequence to compute that, to implement this logic. So it has to know, how do I do that? right? And it's assuming that you have that you're using routing by sequence. Okay, and so all of that stuff, is kind of described a little bit here. If you scroll to the bottom, as I said, dispatching rule usage notes, you need a whole bunch of information for some of these. Anything that involves processing time over the sequence assumes you have a sequence, blah, 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 blah. It's all there. Okay, and this is in the video what I'm going to go through a couple of examples of doing this. Okay, but the key thing to recognize here that I want you to get, at least from our lecture component, let's see, cancel, is this notion of static versus dynamic. With the static, you're basically just giving it an expression and it ranks it once. With dynamic, it recomputes it every time, and you can have a series of complex computations or a series of complex evaluations. And with those complex evaluations, there are various ways you have to tell Simio, use this information. That's what I want to get, what I want you to recognize now. And then we're going to go through and do an example of this in the video. Okay? All right. So let's look at case study 3 for a second. And this is what I kind of drew out by hand here. There it is. I just did a screenshot of the finish station. And if you remember what we do when we create this kind of logic where we go from a transfer node to the servers, we're going to select from list. And what I would like to happen is I'd like to make this decision as late as possible. In other words, I don't want to send an entity, an order entity, to one of the servers if the server's busy. Because if I send it to, say, finish 2, but then finish 1 becomes available, then I can't jump it back up, right? So if I make the decision as late as possible by holding it at the transfer and making the decision then, right, I'm going to make, quote, the best decision. And how do we do that? Well, we set the input buffer capacity on all of these guys to 0. Right? So we set the input buffer capacity on finish 1, finish 2, finish 3 to 0, and that prevented the transfer node because there's no availability until the process is done. Right? Remember, we've done this several times. So now my question is, well, what are the implications of this in the dispatching context? So we have this ranking rule and dynamic selection. Let's say that I want to do earliest due date. Well, what are the implications of the fact that these have 0 capacity buffers on that?
Dispatching doesn't work at all.
Well, it will work, it just doesn't do anything, right? Because you're going to implement a ranking rule like, let's say, earliest due date, but there's no buffer. Right? So when you exercise that due date, there's only going to be one thing there. Okay? So there's no selection dispatching being done. Okay? So we have to make the decision here. Okay? So what we need to do instead is, oops, I gave you the solution without my question of what is the solution. Sorry about that. So the solution is that I'm going to go back in my model and say, you know, instead of looking here at my ranking rule and dynamic selection rule, I'm going to do that here. Okay, and we have that right here, entry ranking rule, and then dynamic selection rule, selection condition, constraint logic, route request logic, request dynamic selection. So we have access, pull this up and then talk rather than try to do all at once. Earliest due date. So we have all of that same logic associated with the transfer node. Okay, and what you're dealing with in the transfer node, remember when we set the watch way back at the beginning of the class, we set the watch to kit, and we looked at that route logic. We looked at the routing out group in particular. This is applying that logic to the routing out group. Okay, and so in this case, you can think about the part of the help that I told you to ignore. Did I already close that? I didn't mean to close that. Sorry about that. I got to pull help back up. Here, let's search for what I searched for before. So look at the server. Go down to dynamic selection rules. That's what I told you to skip that we'd come back to. So now we're at this scenario, right? So I have a queue, my routing out queue, of entities that are waiting, and they're waiting for 3 different servers. So the decision logic is quite a bit more complex, right? So in this case, I have 3 entities, and I have 3 possible servers. So I have 9 possible pair-ups, if you want to think about it that way. Okay, and so you have a series of logic to make, quote, the best decision understanding this this logic. Okay, so it's not quite as simple as saying now shortest, the earliest due date, because I have 3 different servers, right? And so you have static logic, you have dynamic logic, and so on. Okay, and it's all explained here. Kind of hard to understand in here. Hopefully, when I do a video, it'll be a little easier to understand. But that's what's really going on when we implement this logic. And so the key takeaway here before I do the example in the video is that we're making the decision here. And so that as you're implementing this, being able to, say, use watch so that you can view that queue and see what's going on is really important to be able to develop the models. Okay? Any questions for me on dispatching? So what I'm going to do in the video, as I said, is I'm going to actually do some examples. I'm going to look at setting up some dispatching rules for here, some static ones, some dynamic ones, and then look at how to interpret the results. And so note, again, we have this sequence-dependent setup thing going on. So you're going to actually see, so what's going on with this least setup rule and all that kind of stuff. I'm going to do that in the video. Hopefully you guys will follow along. Okay. Questions? Okay. All right, so change gears just a little bit. Said I'd talk about the exam a bit. You graded it? And that's what we got. So here's the score distribution. Here are all of the individual questions. So for new classes that I mentioned way back in the beginning, I've never given tests before. I do a lot of detailed look at the test. So you see there were 15 questions. There were 5 10-point questions. There were 10 5-point questions. You can see the average over the entire class, standard deviation, min, max. I can see what the average was on the 10-point questions, the average was on the 5-point questions. So I use all this information to hopefully look at our testing. Okay, so I'm going to talk about the questions here in just a second, because the questions, in hindsight of looking at the test, I think the questions were reasonable. The questions are all important too. I mean, so all of the topics that were covered in the exam, you want to make sure that you have a good handle on. If you struggled with any of these, you want to make sure you have a good handle on these topics. Okay, so when I look at the scores down here are a little bit lower than I expected for a graduate class like this. I usually expect the majority A's, maybe half as many B's, maybe 1 or 2 C's. And I saw a bigger tail down here than I would like to see. Again, I'm going to go through the questions here in a second, but let me just say that if you are one of the ones who ended up down here, I would welcome feedback to, well, why are you down there? Are my questions terrible? Did I ask you things that I didn't go over? Did you have another test and didn't study? Just what's going on that causes this problem? Okay, so hopefully rectify that. Okay, so you're going to see all this. Grant's going to give these back here in just a little bit, but I'm going to talk before I do that about the specific questions. And the reason I do that before I give you your test back, because as soon as I give you yours, you'll stop listening to me and start looking at your test. And I don't want you to do that. Okay, so I pulled out all the questions here, and the ones in red are the ones that I was like, what's going on here? I felt that the average was quite low. So anyway, context, what is dispatching? I don't think I need to answer that because we spent a long time today talking about that. Related tables is very important. What does it mean for 2 tables to be related? How are these relationships implemented? You basically have 2 different tables and they share a key value. You have a primary key in one table, there's a foreign key in the other table, and that links the rows. That's all I was looking for. What is the job shop scheduling problem? You can use math if you want. What I'm looking for here is you have in jobs, in machines, random sequences. So the sequences aren't all the same, so it's not a flow shop. That was it. You didn't have to give any math notation. You could. You give math notation if you wanted. But it's basically this notion that I have multiple parts and multiple machines and the flows are random. Material, question? Material inventory elements are important parts. What are they? What are the key differences? So material element, in some sense the inventory element also, is measures the consumable resource where you don't need animation and you don't need any characteristics other than a value. Right? So I have 10 units in hand, I can consume that and reduce it, and I can produce it and increment it. And so if I'm only interested in that single value. Okay? The difference between material and an inventory is an inventory adds location information. So where a material is generic for your model, an inventory then adds a location like server 1 or server 2 or transfer node or something. It adds location information. And that was it. Data-driven, data generated. Again, this was one of the red questions that the scores one is what I had hoped. Data generated, if you look at our models, I mean, we always have resource tables that creates the resource instances automatically. In this last one, we have materials elements, a materials table where it created the materials elements automatically. So we have a large portion of the model that's created by table data. And so that's it. You implement the model instances using a table data. Data-driven is the case where we have our, like in case study 3, we have a scenario. A scenario consists of order table, material table, right? And so I'm not having random arrivals. I'm reading that data in and executing from that external data. And so that's data-driven. It's driven by the data. Okay, so again, this is one I'd like some particular feedback again, because it's quite possible that, I glossed over this in the initial part of the class. So yeah. Okay, so next one, the 5-point questions. 2.6 was perplexing to me. What's the difference between sequence-dependent setup, sequence-independent setup, and the perplexity came from the fact that I did this exact thing in the video right before the test. Right before the test, we have sequence-dependent setup. We also have sequence-independent setup in that video and in this problem. And we also talked about it in the very beginning of the class. So sequence-independent setup basically means you incur a setup no matter what the part sequence is. Part gets there, setup. Sequence-dependent setup is like this, where it depends on the sequence of part visitation. If I have a blue and a blue and a blue and a blue, no setup. But if I have a blue then a yellow, I have a setup. So it's dependent on that sequence. And the fact that I'm producing a blue part the setup time can only be computed if you knew what was done before it. Okay, because it can be 0 if I did a blue before it. It can be a big number if I did a red before it or something like that, right? So that's the sequence dependency. What's a non-delay schedule? You have no forced idle time. So a non-delay schedule is one where if any machine is idle and there are jobs waiting for it, it picks one and does it. Make span, 4.9, almost everybody got this. It's good. It's the completion time of the last job. Resource plan, entity workflow. Again, reasonably good there. The resource plan shows the rows are the resources and the components on the row are the objects or the orders or whatever. And in the entity flow, it's the opposite way, where the rows are the entities. Context of scheduling problems, what's the difference between a sequence and a schedule? So a sequence is a permutation of jobs, and a schedule then attaches start and end times to that permutation. So I can tell you that, to this server, for example, the sequence that I follow is 378, job 3, job 7, job 8. That's a sequence. It becomes a schedule when I give you times. And so remember, there are an infinite number of schedules for any sequence if I allow forced idle time. Okay, so that key distinction here is that I have start and end times on a schedule. Many of our Simio models use targets. So a target is you give it a specified value, you give it a target relationship, and it computes. And another key component of that is it lets you characterize the results. Right? So what we used most often was due date. So we checked the completion date against the due date, and it checked it for you, but it also let us categorize the results. That if you were within the time window on time, if you hadn't started, not started, if you were late, late. So it did the computation for us, but it also let us categorize the values into something that's more meaningful to it. When using materials and inventories, how does Simio perform replenishment during a simulation run? So what we were looking for here was basically you define replenishment policy. So for either an inventory or material, I define a policy, and the policy defines parameters for that policy, like reorder point, reorder quantity. You define the parameters. And then when the conditions are met, Simio executes a process that you write, right? So by defining the policy, it doesn't implement replenishment. You have to define the process. And what the process does is you use those parameters to then implement whatever strategy you want. So you had to have the first part of saying you define a replenishment policy which defines the parameters, and then you define a process which implements that policy based on the parameters that Simio gives you. And that was a long-winded way of saying it. I think my answer in the answer key that I gave Grant was like 2 sentences. Okay, so you can certainly be more precise than me. Trace and watch are critical for debugging. Unless someone wants to hear, I'm not going to go there. I've demonstrated both of these today and demonstrated both of these in multiple classes. And so my comment on that one is if you miss that one, either A, you're not doing enough debugging, or B, you were just confused by the question. I hope it was the latter and not the former. Because you will never do complicated semio models without using trace and watch. Just you can't be done. Okay, so 14, many of our scheduling type models, we use custom objects. Why? Again, in video module 3, I gave a perfect example because if you haven't watched it, I make a mistake early in the model. I didn't figure out that I made the mistake until 10 minutes later, right? And so instead of erasing all of that and re-recording it, I went back and said, oh, by the way, I just made a mistake. I'll come back and fix this later, which I do later on in the model. And so again, what this does is it simplifies and makes your model building flexible, right? It simplifies model building and makes the model building flexible is what that does. And finally, queues, ranking rules, and dynamic selection rules. Again, we talked a lot about that today, so I don't think I need to answer that one. Okay, so again, just let me say, all of these concepts are critically important. So if you did struggle with any of these, please let me know where we stand and how we can improve, and make sure that you do know them, because they will come up again. I mean, I'm not saying I'm going to ask you the exact same questions again on exam 2, but I have done that before. So, I find all of these important. Okay? Anyone have any questions for me?
Not yet.
Okay, so let me tell you how this works, because you might have 1 or 2 questions once you see yours. I graded the 10-point questions and Grant graded the 5-point questions. I gave Grant the rubric to use. He just implemented it. So if you have specific questions, if it's the 5-point questions, ask Grant first. And if you're still unsatisfied, come see me. If it's a 10-point question, come see me. Okay? But let me say that think through what you're going to ask. Right? In other words, I don't want you to come and say, look, I don't know why I missed this. I want you to come and explain to me why you don't think you missed it and say, look, here's what I said and here's why that's right. Okay, and if you do that and you are right, I will certainly give you points, but I want you to go through this process. If you miss a problem, go through the process of why did I miss it? That's part of the learning process. Okay? All right, so Grant's going to give you a test back. And then, as I said, let me know if you have questions.
That's scary.
I get you.
Oh, and let me just kind of end on, again, if you are on this lower tail, don't freak out or anything. My number 1 objective is still to make everyone do well in this class. And so part of the reason I want your feedback so that we can fix the situation and improve on it. Okay? All right, thanks, everybody.